Hello, Tom from Every Step Calculus, everystepphysics.com. This is going to be a video on a physics problem regarding a collision between two masses. And what happens is two masses, I think on this oval type of surface, are released at the same time, and they hit head-on, and then the question is, what's their velocity just before they hit, and what's the velocity afterwards, etc. So I'm going to do this problem that I saw on Yahoo, and let's do it physics to get to my main menu. I don't see how anybody remembers this stuff in physics. I mean, everything's related to Newton's second law, you know, force equals mass times acceleration. But it doesn't seem to help me much. But in my physics education. But anyways, we're at collisions. You choose collisions because anytime you have to get used to my programs a little bit in physics. And if there's anything colliding, you go to collisions even though they ask for velocity or acceleration or tension or something like that, which I have menu items for that too, but generally to make it simple, it just triggers your mind to go to collisions. And then collisions are pretty wild too because they have different words, you know, hits, elastic, crashes into couples, and sometimes these words are supposed to make you choose momentum formulas rather than collision formulas. But anyways, in this problem it had collides, the two collide together, so we got to choose number 3 there. You can use the number or the scroll down. I'm going to just press the number 3. And they bounce off of each other, which is elastic. So I'm going to choose number 2. And then what was given was two masses and a height. So I'm going to choose number 7 there. We're going to enter the first mass. You have to press alpha before you enter anything in these FU lines here. You have to go, and the problem is alpha 1.95 kilograms. I would do they gave you grams or something, I would convert it for you, show you how to do that. The second mass is 4.25, alpha 4.25 kilograms again. And the initial height is alpha 5 meters, number 2. So I show you what you've entered. You can change it if you made a mistake. I say it's okay, number 1. And we start our calculations. I'm not a physics professor, so I mean that's the reason I program, because I can't remember this stuff, but it takes me quite a while to figure out what the correct step-by-step solution is with regards to passing a test in physics. So anyways, v squared is equal to 2g height times the height, you know. So you got the square root of 2g height, and the initial velocity of each one is the same because it's a friction-free environment. And so the initial velocity of 1 and initial velocity of 2 is 9.9045 meters per second. press enter. We're going to find the velocity of the center of mass. Velocity of center of mass. You notice that all my programs, I give you this, many professors just put this down and it starts the calculations or whatever. You never know what these things mean, you know, but I was always against that. So when I started a program, I'm going to show everybody what I'm actually making something equal to. And this is, so there's the volume, velocity of center of mass, okay? And this is the calculations. We add the variables. And it turns out to be minus 3.6743 meters per second. Now we're going to have the velocity before collision, so I got indicated VB1 for mass 1. That equals 13.579 meters per second. VI minus the velocity of center of mass. Simple as that, okay? Same thing for the velocity just before it collides with, for mass number 2. That equals 6.2303 as we do the calculations. That's notice VI is the same for initial velocity, is the same for both masses. Now I got VA1, which is velocity after the collision. Turns out to be the center of mass velocity minus the, what we just found here, the velocity before. For mass 1, turns out to be minus 17.253 meters per second. Same thing for the after velocity of mass 2, after collision. Sorry. And that turns out to be 2.556 meters per second. We're asked to find the final height. And what we find in previous calculations are used in the next ones. So here we have the after velocity of collision squared divided by 2 times the gravity, 2 times 9.81, and that equals the height of mass 1, that's 15.172, and the final height of mass 2 is equal to 0.33299 meters. Pretty neat how every step, physics.com. Go to my site, buy my programs, and enjoy passing physics. Have a good one.